the world of generative AI gives us this incredible power, but
Yeah.
let's be honest about the user experience for a second.
Yeah.
You have these amazing specialized models, Google's Gemini for text, you've got Imagen for images, VO for video.
Titans, really.
Right. But when you want them to actually work together on one project, say, turning a simple idea into a finished animated short, the process feels less like magic and more like you're a switchboard operator from the 1950s just juggling API keys and browser tabs.
It's that constant painful fragmentation. You're always jumping between tabs, copying these massive strings of text, and then manually kicking off the next step.
Right.
For any serious creator, you feel less like you're automating something and more like you're stuck on a digital assembly line. It's just tedious.
So our mission today is to do a deep dive into the architecture of a proposed solution for this exact problem. We're exploring the design of a GenAI workflow manager.
A visual workflow manager, which is key.
Exactly. It's built to take that highly complex AI orchestration, that messy handoff of data, and make it as simple as click and connect.
And this dive is, I think, really crucial for anyone who needs to move beyond just a simple prompt and response. We're going to really dissect how you can build automated, repeatable, and, complex creative pipelines.
From the ground up.
From the ground up. Moving from the initial idea straight to the final asset, ideally with no manual steps in between.
The ultimate goal of a tool like this is just pure efficiency.
Mm-hmm.
You take a simple text input, maybe just a cyberpunk city, and it transforms that into a full creative pipeline in seconds. So that means, intelligent text expansion, detailed image generation, smooth video animation, and then even adding ambient audio, all of it running seamlessly from that one little idea.
To really get why that's so powerful, we have to talk about the pain points.
Yes. So to really appreciate the solution, we have to detail the specific pain points this visual manager is designed to fix. Fragmentation, like you said, is the absolute monster.
It is.
Your tools are scattered everywhere. ChatGPT, Midjourney, Runway. You're just bouncing back and forth, filling a digital backpack with results just to carry them to the next spot.
And that bouncing leads directly to the core pain of
Context switching.
Context switching,
Yeah.
exactly. You generate a great, really long prompt in one tool. You have to copy that, paste it perfectly into the next one, and just hope you didn't miss a comma or hit a token limit.
Oh, yeah.
There's zero native handoff. And then, if you want 50 variations of an image, you're running 50 separate jobs by hand. It's a scalability nightmare.
So the essence of what users need help with, it really boils down to two critical things. First, orchestration,
Right.
Making sure the output of Model 1 is correctly formatted and delivered as the input for Model 2. And then state management.
State management. Just
Yeah.
tracking which prompt, which seed, which model version generated that perfect asset you made 3 weeks ago.
Without that, you can't reproduce anything. It's
No.
impossible.
And what's so fascinating here is how the architectural proposal just immediately tackles this by creating a unified visual workflow manager.
Right.
So instead of tabs and copy-paste, you turn these steps into these tangible, draggable nodes on a canvas. The focus shifts from writing code to just designing the flow.
So using that Cyberpunk City example, the whole experience becomes intuitive. You start with an input node, you connect it to a text node that expands the prompt, chain that to an image node, then a video node for animation, and finally an audio node.
And that visual chain immediately tells you everything. It shows the power of the system right there.
It does.
And the beauty is in the details of the feedback. The sources show a user can, select a really complex workflow. They can double-click a node to inspect its exact settings, and then see the results like expand an image or play a video right there in the execution results panel.
So you avoid that painful context switch entirely.
You do. It integrates the history and the live view in one place.
Okay, so let's unpack the high-level architecture. We're looking at a pretty optimized dual language stack here. Flutter for the front end and Golang for the back-end API. So starting with Flutter, why choose this specific framework, especially when the main interaction is a high-demand visual canvas?
Well, the visual canvas is the whole reason. Flutter gives you great distribution one code base for web, desktop, mobile. But fundamentally, if you're building a drag-and-drop editor like this, you need a framework that can guarantee 60 frames per second performance.
Even with hundreds of nodes on the screen.
Exactly. A laggy canvas is the death of a tool like this, and Flutter's rendering engine is just top tier.
Okay, but building the back end in Go, Doesn't that introduce some complexity? I mean, the AI world is so dominated by the Python ecosystem. Was that trade-off worth it?
Oh, it absolutely was. The speed and concurrency of Go are crucial for handling just the sheer volume of API requests these workflows can generate. Remember, you're not necessarily running the heavy AI models in Go. You're using Go as the super efficient orchestrator. It manages the connections, the queues, the state updates via the REST API, and makes sure dozens of nodes can run at the same time without bottlenecking anything.
So Flutter is the beautiful, fast interface, and the Go backend is like the hyper-efficient traffic cop routing all the data.
That's a great way to put it.
What's the core intelligence layer on the front end then?
The absolute heart of the app is what the sources call the canvas, which is managed by the workflow provider. This provider handles the state of all the visual stuff, the draggable nodes, the connecting edges. But the most robust technical feature here is the Underrato system.
Underrato. That's notoriously complex in any graphical editor, isn't it? Especially when moving one node could mess up the layout of dozens of others.
Yeah.
How do they guarantee stability?
They do it using a classic software engineering solution, the command pattern. So think of it less like erasing history and more like keeping a detailed financial ledger. Every single action moving a node, creating an edge, is wrapped in a specific command object, like a move node command.
I see. So every action is a complete reversible transaction.
Exactly. When you hit undo, the system just reads the last command on the stack and reverses that single defined action perfectly. Without this pattern, managing state reversal would just lead to instability and, honestly, data corruption really quickly.
So the command pattern is the foundation of stability for the user.
It is.
And finally, bridging the slick front end and that powerful back end is the service layer, the workflow API service.
Right. This layer just abstracts all the back-end communication. Whether you're getting a list of workflows or executing the entire graph, it handles the JSON. And there's a small but really helpful developer detail built in, a mock fallback.
A mock fallback.
Yeah. It means the Flutter app can run and function perfectly with local mock data, even if the Go server is down. It just speeds up front-end development and testing so much.
Okay, now we get to the core challenge, execution. We have this beautiful visual network of connected boxes, but a computer can't run a diagram. How does the application decide the sequence? It needs a linear set of instructions.
This is the fundamental problem of the directed acyclic graph, or D. The workflow has to be a diag. It has to be a one-way map where you can't loop back to where you just were.
Otherwise, you'd get an infinite loop.
Right, the system would just get stuck. So to execute this map efficiently, the application uses topological sort, specifically Kahn's algorithm.
So topological sort is the magic here, is the process that takes that visual map and flattens it into a guaranteed checklist. It says, run the text node first, then the image node, then the video node, making sure nothing starts until its inputs are ready.
Precisely. It solves the dependency problem instantly. But if that was all it did, it would just be a scheduling tool. There's a much more creative function here, which the sources call the secret sauce.
The loop node.
The loop node, yes.
Yeah. And its specialized system prompt, which they call the muse. I find this just brilliant because it elevates the tool from a simple utility to a generative idea machine. It doesn't just loop the same input.
No, it doesn't. It forces creative divergence at scale. The loop node uses the specialized system prompt, the muse, and it takes a simple seed, let's say architecture, and instead of just running the workflow once, the prompt generates 5 distinct high-concept ideas related to that seed.
So things like a brutalist structure overgrown with neon moss, or a utopian skyscraper built of crystalline light.
Exactly. It generates the diverse ideas first.
That's a massive efficiency jump. Yeah. The engine sees the loop, it extracts these 5 creative seeds, and then it runs the entire downstream pipeline image, video, audio for each unique seed.
Which means your one simple text input gives you 5 unique, fully generated, high-quality video outputs complete with sound, and that's all supported by a robust hybrid execution model.
Let's talk about that hybrid model. Mode A is simple server-side execution. You send the workflow ID to the back-end Go server.
Right, which is great for long-running background jobs where you don't need moment-to-moment feedback.
But the more user-friendly mode has to be mode B, where the client, the Flutter app, orchestrates the flow node by node.
Yes. Client-side orchestration is essential for the user experience because it lets the Flutter app provide real-time progress bars and visual feedback right on the canvas.
So you can actually watch the border of the node change color, or see a loading spinner on the exact task that's running.
Yeah, it gives you confidence that the system is actually working.
Now, this orchestration power is nothing if it can only talk to one vendor. So how does this architecture handle connecting to dozens of different AI providers? From Google's APIs to local models running on your own machine.
They handle this with the AP Provider Service. It acts as a central registry for all the AI backends, and it handles all the dynamic configuration API keys, base URLs, all of that.
And the scope of connectivity is really wide here. You have their internal wrapper, the GoAPI, which handles things like Gemini 3, Imagen 4, and Veo 3.1.
Right, and direct access to Google GenAI. But what makes this architecture so special is the commitment to local open source models through the OpenAPI provider.
So you can integrate local LLMs running via llama.cpp, lm-studio, Llama.
Yes, to run models like Qwen 3 or Gemma. They also specifically support local image generation via Focus, which is stable diffusion, and local video generation with FramePack, so you're never locked into one ecosystem.
That brings up a critical technical detail then. How does the application decide which provider to use for a specific node, and how does a code handle that complexity cleanly?
The underlying mechanism for switching between, say, Google's API and a local Llama instance, that's handled by the AP Provider Service using the factory pattern.
Okay, that sounds like serious developer jargon.
Yeah.
How does the factory pattern actually benefit the end user here?
Well, it simplifies the complexity. When a text node needs to run, it just asks the factory for an API service. If the node is set to Google GenAI, the factory creates a Google API service object. If it's set to OpenAPI for a local model, it creates a separate OpenAPI service object.
So the node itself doesn't care how the service connects.
It doesn't care. It only cares that it gets a structured result back.
Okay.
And this modularity keeps the whole application from becoming a spaghetti of vendor-specific code.
Okay, we've built the flow, we've handled the dynamic execution. Now for the crucial question, data persistence. If I generate 50 videos and 200 images, how does the tool remember all those runs and their exact parameters?
Data persistence is absolutely paramount for state management. All the structured data is stored in the backend database, which is PostgreSQL, and most of the configuration and results are stored efficiently as JSON objects.
And there are 3 core tables that define the structure. You have the workflows table, which holds the visual structure nodes, edges, positions. Then you have APA providers for the configuration details.
And running services, which is a clever little table that stores commands to start and stop services on demand. Super useful when you're running local models like a Llama that you only want to boot up when you need them.
But the real power, the ability to replicate and learn from past successes, that comes from the 4th element, the execution results table.
Absolutely. This is the key to all historical tracking.
So every single workflow run is saved there.
Every single one. Each entry contains the timestamp, the final status, and most importantly, a complete map of results for every single node in that workflow. This means you can genuinely go back in time and see exactly what prompt created that viral video you made 3 weeks ago.
No more losing that perfect image because you forgot the seed or a hidden prompt.
Exactly.
Let's trace a simple data flow. Let's use the cat in a spacesuit example to see this in action.
Okay, so a user types a short input, like a cat, into the text node. That node already has a custom system prompt inside it to expand the idea.
Right.
The app calls the execute endpoint, the backend calls the Gemini API, and Gemini returns this expanded prompt. Hyper-detailed 4K photorealistic 3D render of a tiny cat in a spacesuit floating in a nebula.
And that result is instantly logged in the PostgreSQL execution results table, marking that the text node is done.
Correct. So when the next node, the image node, starts, it doesn't wait for the user. It just retrieves the previous node's final logged output, that long, detailed prompt, and automatically uses it as its own input to generate the image.
So the database is essentially the workflow's persistent automated memory.
Yes. It ensures zero degradation or manual copying errors between the steps.
This whole system, from the visual UI and Flutter to the Go backend, handling the sorting and the data, it all culminates in this seamless, high-quality output.
The output potential is enormous. You get these rich, creative narratives from the prompt enhancer, you get cinematic video clips, you get high-detail 4K images. It turns a single idea into a cohesive, polished product.
And the viral factor here, as the sources called it, is really enabled by 2 things working together. You have the loop node, which creates these cohesive series of content from one keyword, and the detail execution results panel, which basically acts like a searchable history gallery. You can just click the previous result button and browse your history to find what worked.
And if we connect this foundation to the bigger picture, the architecture they've designed is just inherently future-proof. I mean, what happens when these visual workflows aren't just about orchestration, but they include complex agents?
Nodes that can browse the web or read documents to gather context before they run.
Exactly.
Or what about a code execution node? One that lets you drop a snippet of Python right into the visual flow to handle some kind of bespoke data manipulation.
Precisely. And the biggest shift this foundation enables is the creation of a community for sharing these complex workflows. Once the architecture is solid and the flow logic is clear, the real value comes from other people using and iterating on the creative pipelines you've built.
That really emphasizes the long-term application here.
It does. It's about turning sophisticated AI workflow design into a communal, accessible art form.